Super, wonderful. We're going to do this non-routine problems from as preparation or kind of practice for the AMTI round 1. So a bunch of very interesting questions which you're going to solve today. We're going to show you the questions, solve them one by one, step by step. These are the questions that have been asked for classes 5 and 6. Wonderful questions, wonderfully tricky questions, not easy. As I do straight away, the bunch of things that I would want to tell you, take this, enjoy these questions, do them with fun. Don't try to rush through them. You have to get the funda right and the detail right. You have to get how to do it and make sure you don't make any mistakes. And so don't rush through this. Do not look to solve these questions quickly. Your speed will come automatically. It's not going to come straight away on day one. The more you practice these kind of questions, the more your mind will open up to figure out new ideas. But prima facie, I can tell you straight away, don't rush. Do these questions slowly, which is why it is very advisable to try these questions before you attend the session. So if you have not tried these, you're going to be part of this session right now. That's all right. But at any point of time, you find an interesting question, it's on YouTube, you put pause, try the question, then go through the rest of the video. Lovely. So let me start without further ado. Let's start off and see how we can solve this question. A 3-digit number with digits A, B, and C in that order is divisible by 9. So we have a 3-digit number A, B, C, that's divisible by 9. A is an odd digit and C is an even digit. So A is odd, C is even. Right? So A can be 1, 3, 5, 7, 9. C can be 0, 2, 4, 6, 8. B and C are non-zero. So C is not 0. And B is non-zero. So it can be anything from 1 to 9, but it's not 0. Okay. The number of such 3-digit numbers, so they're not asking us to find one number, they're asking us to find the number of such numbers. Right? So key thing here, know the condition around A, condition around C. We don't have to worry about the condition around B that much. It's not 0. That's all we need to remember. Right? So there might be several form-like methods of doing it, but we don't want to do any of that. We want to see if we can approach this methodically, step by step, and get to the answer. And so the A is odd, 1, 3, 5, 7, 9. C can be 2, 4, 6, 8. We know that this number is a multiple of 9. We know the test of divisibility by 9, which effectively sum of all digits should be a multiple of 9. I'm going to start by making a very simple starting point. Let's say A is 1. Start with that. Let me put A as 1. C can be 2, 4, 6, 8. So I'm thinking about the numbers which are 1-2, 1-4, 168, 1-8, 1-6. And so starting with 1, these are the 4 possible numbers. I'm not saying all 4 are possible. We've not yet filled the digit B. But this is what we are thinking about. Right? Now we know the number is a multiple of 9. Right? So sum of the digits should be a multiple of 9. If you add these two add up to 3. Right? The sum should be a multiple of 9. So sum of the digits should be 9 or 18 or 27 or something like that. We add these two, which add up to 3. That means the sum can only be 9. It cannot even be 18. And so if you put 6 in between, 162 is a beautiful multiple of 9. First digit is odd, last digit is even. The number in between is not 0. All conditions satisfied, 162 works. The sum of the digits becoming 18 is not possible. 1 plus 2, 3. 3 plus 15 is 18. So middle digit cannot be 15. 1-4. 1 plus 4 is 5. 5 plus 4 is 9. 1-6. 1 plus 6 is 7. 1-8. 1 plus 8 is 9. 0. Are all 4 numbers possible? 162, 144, 126, 108. Wait a second. 108 is not possible. Why? Because we know B cannot be 0. This cannot be 0. But hey, remember, 108, the digits add up to 9. We can have a scenario where it is 198, where the digits add up to 18. And so 198 digits adding up to 18, that's still a possibility. Sum of the digits has to be a multiple of 9. We're not told that sum of the digits should be 9. And so 162, 144, 126, 198. Only in this case could we have the digit adding up to 18. In these scenarios, we cannot have 18. Right? We got the hang of it. Let's move on. Let's put the digit as 3. First digit as 3. 3-2, 3-4, 3-6, 3-8. 3 plus 2 is 5. This could be 4. 3 plus 4 is 7. This could be 2. When 3 plus 2 is 5, adding up to 18 is not possible. 5 plus 13 is 18. The digit cannot be 18. 3-6. This could be 0. 0 is not possible. It could be 9. Wherever we get a 0, make sure you're not counting the 0 possibility. Make sure you're counting the 9 possibility. So 3-6, 306 does not work. 396 works. 3 plus 8 is 11. 11 plus 7 is 18. In this case, they cannot add up to 9. That's not possible. So with starting with 1, there are 4 possibilities. Starting with 3, there are 4 possibilities. Let's start with 5. 5-2, 5-4, 5-6, 5-8. 5 plus 2 is 7. This could be 2 adding up to 9. It cannot add up to 18. 5 plus 4 is 9. This can be 0. 0 can't work. 9 will work. 5 plus 6 is 11. 11 plus 7 is 18. 5 plus 8 is 13. 13 plus 5 is 18. Lovely. Starting with 1, we have 4 numbers. With 3, we have 4 numbers. With 5, we have 4 numbers. It looks like starting with 7 and 9 also we'll have 4 numbers. Let's not take it for granted. Let's write it down. 7-2, 7-4, 7-6, 7-8. 7 plus 2, 9. This can be 9. 7 plus 4, 11. 7 plus 6, 13, 15. These go up by 2. These come down by 2. 9-2, 9-4, 9-6, 9-8. 9 plus 2, 11, can be 7. 9 plus 4, 13, 5. 9 plus 6, 15, 3, 9, 1, 8. We have tried all combos starting with 1, 3, 5, 7, 9. We know that C can take only values 2, 4, 6, 8. When A is 1, C is 2, 4, 6, 8, all work. A is 3, 2, 4, 6, 8, all work. A is 5, 2, 4, 6, 8, all work. 7, 9. In all starting points for A, 4 different possible values for C work. A could be 1, 3, 5, 7, 9. C could be 2, 4, 6, 8. Any combination works. So select A from 1, 3, 5, 7, 9. Select C from 2, 4, 6, 8. Any combo works. There will be an appropriate B and only one appropriate B for each of those combinations. And so 5 into 4, 20. 20. Beautiful question. We are using multiple ideas. First one, A is odd, 1, 3, 5, 7, 9. Second one, C is even and not 0. So 2, 4, 6, 8. Third idea, the fact that the number is a multiple of 9. So the digit should add up to 9, 18, 27, one of these. Digits cannot really add up to 27. Only 3-digit number that adds up to 27, 999. That's not possible. We know that. So it will add up to either 9 or 18. The only thing we need to keep in mind is that B also cannot be 0. So be careful of the idea that B cannot be 0 when you're trying this question. Otherwise, very doable, very simple. These questions are tough. You need to grab the idea and time consuming. And when it's tough and time consuming, the one thing you cannot afford is to get something wrong. I've seen several students get the idea, spend time on it, get something wrong and land up at 16. So do it. Make sure you build this habit of not making mistakes. Very crucial. Okay. Lovely. I'm going to go to the next question. The number of non-negative integers which are less than 1000 and end with only 1 0. Non-negative integers, positive integers, less than 1000 and end with only 1 0. A lot of these questions I really like to see. Write down one number that works. I want a number that ends with a 0. 10. The moment I write 10, I can put 20, 30, 40, 50, 60, 70, 80, 90. I've written this far, I might as well put 100 also. Will 100 get counted? We're thinking about numbers that end with only 1 0, so 100 won't get counted. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Lovely. 9 numbers. But this is 9 numbers that are all 2-digit numbers. But you have to check numbers that are less than 1000. Is there a 3-digit number that ends only in 1 0? Something, something, 0. 540, 370. All of them are there. Now let's count with some pattern. 10, 20, 30, 40, 60, 70, 80, 90 has worked. Obviously, this 10, 20 can be replicated for 110, 120, 130, 140, all the way till 190. We will not count 200. We see a pattern emerging. If 110, 120, 130 till 190 comes, obviously 210, 220 till 290 will come. 310, 320 till 390 will come. 410, 510, 610, 710, 810, 910, 920, 930, all the way till 990 will come. Lovely. 9 numbers in this list. 9 numbers in this list. 9 in this list. 9 in this list. All the way till 9 in this list. Brilliant. So we have how many sets are there? We know that you're through. This is a set of 100, this is a set of 100, set of 100, set of 100. So 0 to 100, 100 to 200, 200 to 300, or 201 to 300, 301 to 400. Be careful with detail. We add all of them up. There are 10 vertical columns that should be there. Each of them gives us 9. 9 into 10, 90. It's brilliant. We've got the funda, we've got the answer. But have we got it right? We said, the question says number of non-negative integers. We looked at it and said non-negative integers, therefore positive integers. There's an issue. Non-negative does not mean positive. It's not negative. It may not be positive either. There is one beautiful, excellent, wonderful number that's not positive, that's not negative. 0. This number ends with a 0. That should also get counted. It ends with only 1 0. So it's not 90, it's 91. Get the funda right, count carefully, be worried about detail. The final detail matters. You have to worry about why they have given non-negative. Why did they not say natural numbers? Non-negative integers is not natural numbers. Positive integers means natural numbers. Non-negative means set of whole numbers. 0 sits in that list. So be wary of that. Lovely. The digits of the year add up, the year 2000 add up to 2. In how many years has it happened since the year 1 till this year 2021? Year 1 AD till this year 2021, where the digits add up to 2. And brilliant. So we are counting all years from 1 to 2020. All of that. 2021, whether you include or not, doesn't matter. The digits don't add up to 2. So I'm going to break it down very simply. I'm going to think about this as numbers. Right? So single digit numbers, 2 digit numbers, 3 digit numbers, then 4 digit numbers till 2020. And think about single digit number. So 1 digit number where the digits add up to 2. We know this one. 1 digit number where the digit adds up to 2. Single digit number. That's easy. 2. Lovely. And let's build on this. Let's talk about 2 digit numbers. The digits should add up to 2. 2 digits add up to 2. It can be 2 and 0 or 1 and 1. Right? So put 2, 0, 1, 1. We don't have to worry about 0, 2, because if you put 0, 2, that's just 2, it becomes a single digit number that we have already counted. Right? How many single digit numbers are there? Only 1, that's the number 2. How many 2 digit numbers are there? 2, 0, 1, 1. Got you this far. It's very simple. Think about 3 digit numbers. Only way you can add up to 2, either you have just a 2 or you have 1 and 1. But you want 3 digits. So how will you do? You just have just a 2 and then have 2 zeros to go with. Or you have 2 1s and a 0 to go with it. We can have 1 1 0 or 1 0 1. Both are possible. You have 2 1s. The first digit has to be a 1. First digit cannot be 0. So 1 1 0, 1 0 1. Next, what do? We'll think about 4 digit numbers. 4 digit numbers could just be 2 or it could be 1 and 1. If it is just 2, it is followed by 3 zeros. If it is 1 and 1, it is followed by 2 zeros. So 1 1 0 0. Where else could it be? The first digit is 1. It would be 1 0 1 0 or 1 0 0 1. The first digit is 1. So the 1 0 0 can be arranged in several ways, in second, third and fourth positions. It will be 1 0 0, 0 1 0, 0, 0, 1. And so how many are there totally? 1 single digit year, 2 2-digit years, 3 3-digit years, 4 4-digit years, 1 plus 2 plus 3 plus 4, that is 10 years. There have been 10 years from 1 AD till 2021, where sum of all the digits of the year add up to 2. Do about it methodically. Say I'm worried about 1 digit, 2 digit, 3 digit and 4 digits. 1 digit, there's only one number possible, digit 2. 2 digits is 2 and 1 1, so 2 0 and 1 1. The moment you get this far, this part becomes easier. I know that 2 can be written as just a 2 or as 1 1. So how many ever digits are there? Everything else is 0. So 3-digit number 2 0 0 1 1 0 0. Sorry, 1 1 0. So 3-digit number 2 0 0 0 1 1 0 0. So we know what sits inside the 2 1s and a 0. In how many ways can that be arranged? It can be 1 1 0 1 0 1. Here it could be 1 1 0 0 1 0 1 0 1 0 0 1. So totally 1 plus 2 plus 3 plus 4, 10 possible years are there. Can be careful with detail, get the funda, do it methodically. Several of these questions become simpler. You just write down 1 year. You say, okay, the year 2 works, year 20 works, year 200 works, year 2000 works. That's another way of starting and going about it. Everything with just 2, only 2 in it. 2, 20, 200, 2000. Everything with 1 1 in it. Then it could be 1 1, 1 1 0, 1 0 1. Then these 3. Another approach for it. So do this methodically, do it slowly, do it carefully. And so how many years are there? 10 of these are there. A certain number has exactly 8 factors, including 1 and itself. 2 of its factors are 21 and 35. The number is exactly 8 factors. 2 of its factors are 21 and 35. I don't know what kind of number has exactly 8 factors, but I know this number is a multiple of 21 and 35. So I'm going to write down multiples of 21. 21 is a multiple of 21. 42 is a multiple of 21. 63 is a multiple of 21. 84 is a multiple. 35 is a multiple of 35. 70 is a multiple of 35. 105 is a multiple of 35. Beautiful. A number is a multiple of 21. 21 has sitting inside it 3 and 7. 3 and 7 are co-prime. They are both prime numbers. They are relatively prime with each other. Or this number is a multiple of 3 and it's a multiple of 7. It's a multiple of 21. It has to be a multiple of 3. It has to be a multiple of 7. It's a multiple of 35. 35 is 5 into 7. It's a multiple of 5. It's a multiple of 7. So our beautiful number, based on the information given to us, we can say that it's a multiple of 3 and 7 and 5 and 7. Put these two together. Put these two pieces of information together. It's a multiple of 3 and 7 and a multiple of 5 and 7. 3 and 7 and 5 and 7. So think about it. 7 is sitting both of these places. So our number is a multiple of 3, it's a multiple of 5, it's a multiple of 7. So the number we are looking for is a multiple of 3, 5 and 7. Or 3 into 5 is 15, 15 into 7 is 105. The number we are looking for is a multiple of 105. We are able to multiply these 3 and go to 105 because they are co-prime. 3, 5 and 7 have nothing in common. If you think about it, what we are elaborately doing is finding the LCM of 21 and 35. Number is a multiple of 21, it's a multiple of 35. Then it will be a multiple of the LCM of 21 and 35. LCM of 21 and 35 is 105. The number we are looking for is a multiple of 105. That much we know. But let's look at this 105. So our number could be 105. It could be 210. It could be 315. It could be 420. It could be 525, etc. Any of these. Right? But we know that our number has exactly 8 factors. And so any one of these numbers or whichever one of these numbers has exactly 8 factors, we find that number, we are through. Right? I want to think about 105. Think about how many factors 105 has. 105 is 3 into 5 into 7. We can write it as 1 into 105. or 3 into 5 into 7 is 35, or 5 into 3 into 7 is 21, or 7 into 3 into 5 is 15. It's not a multiple of 2, it's not a multiple of 4, 6, 8, it's not a multiple of 9, 10, 11, 12, it's an odd number. I think once you have written these 4, we have written on pretty much everything. So the factors 105 has are 1, 3, 5, 7, 15, 21, 35, 105. How many factors does it have? 1, 2, 3, 4, 5, 6, 7, 8. 105 has 8 factors, or that is the number we are looking for. Lovely. Now 210 might also have 8 factors. 420 might also have 8 factors. So let's worry about that. Now 210 is a multiple of 105. All of these will be factors of 210. Is there any other additional factor for 210? Yeah, 210 is an even number. 2 is a factor. There is already a 3 present in it. 6 is a factor. 10 is a factor. So 210 has factors apart from these 8. So any multiple of 105 will have all the factors of 105. And at the very least, itself, 210 is a factor of 210. 315 is a factor of 315. 420 is a factor of 420. So if 105 has 8 factors, any other multiple of 105 will have more than 8 factors. So the number that has exactly 8 factors, 105 has 8 factors, and 105 is the only possible answer. The others don't feature. These will all have more than 8 factors. Lovely. So 21 and 35, put them together, get to the number, then do some trial and error, then eliminate all of this, list the factors, and make sure for yourself you're good to go. Oh, it's a beautiful question. It's a very tough question. So I'm going to give you maybe a minute to read it, take stock of it. Meanwhile, I'm going to have a look at the chat to see if there are some questions, any comments that students have given. I'm going to have a look at that. I want you to read the question and try out that question. I'll give you 1 minute. Fine. So lovely. So the students seem to be having a conversation. So LCM is the answer. Coincidence? I don't think it's coincidence. It's scientific. Lovely. So I'm going to go and jump in and have a crack at this question. It's a beautiful question. Right? So the least number of numbers to be deleted from the set 1, 2, 3, 4, 5, 6 till 16, so that the product of the remaining numbers is a perfect square. Incredibly tough. Incredibly tough. And the product of the remaining numbers. We are deleting some numbers. And so I'm going to think of it. First, I'm going to write down all numbers. I'm going to start from scratch. I'm going to think about 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11 into 12 into 13 into 14 into 15 into 16. Right? Now I'm going to think about numbers assuming this is the perfect square. If you remove some number, I want to think whether it will continue to be a perfect square. And so I want to remove some numbers. What is the least number of numbers to be deleted in order for the product to be a perfect square? Think about it. If I delete everything except 1, I'll have a perfect square. 1 is a perfect square. If I delete everything except 4, I'll have a perfect square. Everything except 9, I'll have a perfect square. So I can delete 15 numbers and have a perfect square. That I know. Right? Now, I can probably delete everything except 1 and 4. I'll still have a perfect square because 1 into 4 is a perfect square. I can delete everything except 4 and 9, still have a perfect square. Or delete everything except 1, 4 and 9. 1 is a perfect square, 4 is a perfect square, 9 is a perfect square. I multiply these 3, I'll still get a perfect square. I can multiply 16 also, still get a perfect square. So out of these 16 numbers, if I delete everything else except the perfect squares, then I'll have a perfect square. 1 into 4 into 9 into 16 is a perfect square. So if I can create perfect squares, remaining. Then if I eliminate the rest, then I'm through. 1, 4, 9, 16 I have. Delete the remaining 12 numbers, we are good. But 12 is not there in the choices. And we are told that we want to delete the least number of possible items. So there is some other mechanism we have to think about. So 1 into 4 into 4 into 9 into 16, this is the perfect square. I can have this as my perfect square. The remaining 12 numbers I will delete. Brilliant. But as the choice is telling me, I don't have to delete 12. I can delete far fewer, you still have it. How does that happen? I don't find any other perfect squares here. Right? Is there a mechanism of generating a perfect square from the remaining numbers? If I want to try that out, what do? I'm going to remove 1, I'm going to remove 4, I'm going to remove 9, I'm going to remove 16. I'm going to stare at the remaining numbers. Is there some combination I can extract out of these that will result in a perfect square? Think about it, it's very important. So I have 2, 3, 5, 6, 7, 8. Can I combine some of these to get a perfect square? Think about it. There's a 2 here. If I can find one more 2 somewhere, that's a perfect square. There's a 3 here. If I can find one more 3 somewhere, that's a perfect square. Lovely. 2, 3 can be combined with another 2, another 3 to give me a perfect square. What can I do? 2, 3, 6. 2 into 3 into 6, 6 into 6, 36. That's a perfect square. So from here, if I eliminate 2, 3 and 6, or here if I include 2, 3, 6, this is a perfect square. So I have picked up 7 numbers out of this 16 and I've got myself a perfect square. That means I could have removed, deleted the remaining 9 and it will be great. So if I can delete 9 numbers and I can end up with a perfect square, brilliant. But look at it, we don't have 9 in the choices. So 9 is also not the answer. 15 was not the answer, 12 was not the answer, 9 is also not the answer. But now I've got myself a method. I put 2, 3 and 6 together and got a perfect square. Can I put something else together and get one more perfect square in some combination? Then I'm through. Right? Now I'm going to think about it the other way also. Where can I never find a perfect square? What can I never handle? Think about it. If all these numbers, is there some number that can never be combined with something else to get a perfect square? 5, do we have another 5 here? Yeah, we do. We have a 5 in 10. We have another 5 in 15. So maybe we can combine a 5 and a 10 to get a 5 square. 7 and 14 to get a 7 square. Is there something that simply cannot be put with another number? Simply cannot be combined. Has to be removed. There is no way of combining with something. Yeah, I have those numbers. I have a 11 sitting here and I have a 13 sitting here. There is no way 11 can be part of the remaining. Why not? Because I have 11 and it is part of a perfect square. I should have another 11. There is no another 11 possible. So 11 and 13 have to remain. They will have to be there finally, or they have to be removed, not remain. They have to be removed, because if I don't remove 11, it will be sitting inside my remaining thing. There is only one 11 in the system, so that cannot be part of a perfect square. So 11 and 13 will definitely remain. Right? Now let's see, what are we left with? I'm going to redo this, rewrite this, because it got confusing. I've cancelled some things, not cancelled some other things. So I'm going to write it down all over again. I have 1, 4, 9, 16, 2, 3, 6. I can retain all of this. Right? And 11 and 13, I have to remove, definitely. So I'm going to write down the remaining numbers. 1, 2, 3, 4 are gone. 5 is there. 6 is gone. 7 is there. 8 is there. 9 is gone. 10 is there. 11 and 13 have to be removed. So I will not write down 11. 12 is here. 13 has to be removed. I'm not writing that down. 14, 15. Think about it. 1, 2, 3, 4, 5, 6, 7 numbers are being retained. 2 have to be kicked out. 7 we still have to evaluate. Right? These 7 we still have to figure out. Now, just like how we got a 2 into 3 into 6 for 6 square, can we get some other square carved out here? If we can, we are through. How do we do that? 5 into 8 is 40. 5 into 10 is 50. 8 into 10 is 80. None of these are perfect squares. And so 5 into 8 doesn't work. 5 into 10 is 50. That has a 5 square in it. 5 into 10 into one more 2 from somewhere, we are through. Because 5 into 10 is 50, that is 5 square into 2. One more 2 from somewhere, we are through. Or 8 is 2 cube. So I'm going to write this as 2 cube. I'm going to write this as 2 into 5. This is just 5. So think about this. If I combine 5, 8 and 10, I'll be combining 5, 2 cube, 2, 5. So there are 4 2's and 2 5's. 5 into 8 into 10 is 400. 400 is 20 square. Brilliant. So 5, 8, 10 can be retained. I'm going to remove all of this and say I'm going to retain these also. Brilliant. So 1, 4, 9, 16, 2, 3, 6, 5, 8, 10. So 7 plus 3, 10 can be retained. Out of 16, 6 can be kicked out. But even 6 is not there in the choices. So what is that telling us? They're telling us that even after this, all this, from the 7, 12, 14, 15, we can still carve out some square. Or in some combo, we can carve out a square. How do we do that? 7, 12, 14, 15. We need to carve out a square from here. How do we do that? 7 and 14 if we carve out, that is 7 square. And a 2 remaining. How do we accommodate that 2? What will happen to that 2? That cannot be combined with a 12 to give a square. That cannot be combined with a 15 to give a square. There's something funny happening here. We still cannot combine this. But the answer is telling us that it can be combined in some other form. So what is that giving us? That is clearly telling us that 7 and 14 are combined in some way to give a perfect square. Somewhere it is 7 and 14 are being combined to give a 7 square. So we have missed something in the way we are combining these. These 4 go together. But maybe we shouldn't have put 2, 3 and a 6. Maybe we shouldn't have put 5, 8 and a 10. Maybe we can combine with a 12 to generate something. Maybe we can combine with a 15 to generate something. So let's see if we can rejig this. And so 5, 8 and 12, 5, 8 and 10 is an easy combination. So I'm going to not do that. I'm going to retain 5, 8 and 10. So we have 5, 7, 8, 10, 12, 14, 15. And so 12 and 15 are tricky customers. I'm going to think about 12 and 15. 12 into 15 is 180. And so 12 into 15 is 180. That is 36 into 5. So 12, 15 and 5, we can combine them together. Can we? 12, 15, 12, 15 and 5, we can combine them. Can we do that? 12, 15 and 5, these 3. That will be a perfect square. So we'll have 7, 14, 8 and 10 remaining. 7, 14, 8 can be combined together. Think about it. 7, 14 and 8, 12, 15 and 5, they can be combined together. How so? 12 into 15 into 5. This is 3 into 4 into 3 into 5 into 5. 3 square into 2 square into 5 square. So these 3, 12, 15, 5, we can eliminate. Remaining what we have, 7, 8 and 14. 7, 8, 14. 7, 2 cube, 2 into 7. If we combine this, we'll get 7 square and 2 power 4, or 7 into 2 square, the whole square. 28 square is this. So if you go back to this spot, we can remove 5, 12, 15, we can remove 7, 8, 14. All of these combine to give us beautiful squares. So with a 10 finally remaining. So 10, 11, 13, if we delete that, then we'll get a beautiful perfect square. So with removing just 3 numbers, we can get there. Right? Now I'm going to just do a very quick recap. So what have we written down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We said we'll have to cut off 3 numbers. The 3 numbers we're taking out are 11, 13 and 10. The remaining should be a perfect square. How will it be a perfect square? This is a perfect square, this is a perfect square, this is a perfect square, this is a perfect square. Brilliant, we've got those. This is 2 into 3 into 6 carves itself out. That's a perfect square. Then what did we do? We said 12, 15 and 5. They carve together and give us a perfect square. Then what do we have? We have 7, 8, 14. There, that's a perfect square. So all the remaining can be clubbed together in different combination to finally give us a beautiful perfect square. What we cannot accommodate are 11 and 13. After we acknowledge that we cannot accommodate 11 and 13, we can then recognize that 10 also has to be kicked out. There's a beautiful another way of doing this. I want you to think about that. The product of all of these, write in terms of the prime factorization. Fine. So you write down the prime factorization of all these numbers and think about the product. The moment you do that, and you think about that overall prime factorization of 1 into 2 into 3 into 4 into 5 into 6, all the way to 16, you know what prime factorization is. Write down the prime factorization of each of these and put all the prime factorizations together. You'll recognize that 11 and 13 cannot be paired up. Not just that, beyond 11 and 13, a 2 and 5 cannot be paired up. So take away the 11 and 13, take away 2 into 5, 10, remaining everything can be paired up. And therefore, removing 3 numbers is sufficient. So beautiful question. If you start from the prime factorization part, it is obviously much simpler. But you're young, so you might not go about using the prime factorization method. So do it by this method, struggle a lot, and then say, hey, maybe I can do prime factorization also and try prime factorization. That's a beautiful method. Obviously, that beautiful methodical formulaic method I'm not going to give here. That's for you to try. The largest positive integer which cannot be written in the form 5m plus 3n, where m and n are positive integers is. All of this cannot be written questions I don't like. I like questions which are can be written. What is possible? I don't want to think about what cannot be written. And so what cannot be done, I don't want to think about. I want to think about what can be done. And so forget about this question. I don't want to find the largest number that cannot be written. I want to find that some number that can be written as 5m plus 3n. M and n are positive integers. Positive integers 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The best possible case, put m equal to 1, n equal to 1. Write down that number. M equal to 1, n equal to 1. That is, we are adding 5 into 1 plus 3 into 1. 5 plus 3, 8. 8 can be written. Beautiful. So 8 is a possible number. Obviously, 8 is not among the choices. They are asking us for cannot be written. We are finding what can be written. 8 can be written. So we've got 8 in place. Now we want to think about, can some other number be written? We put m is 1, n is 1. We can put m is 1, n is 2. And so that is 5 into 1 plus 3 into 2. 5 plus 6, 11. What are we doing? To this, we are adding a 3. 5m plus 3n. 1 5 and 1 3. We could have 1 5 and 2 3s. 1 5 and 3 3s. 1 5 and 4 3s. What could we also have? We could have 2 5s and 1 3. 3 5s and 1 3. 3 5s and 2 3s. 5 5s and 4 3s. 6 5s and 11 3s. All of those are possible. And we've not only found one number that is possible, we found 2 numbers that are possible. We can now find 3 numbers, 4 numbers, 5 numbers, 10 numbers, 15 numbers. I'm going to do that. I know what can be written, so I'm going to go ahead and write down a bunch of numbers. What is possible? 8 is possible. 11 is possible. 9, is it possible? 9 is not possible. 9 doesn't look like 9 is possible. 5 plus 3 is 8. One more 3 we can add, but we cannot add one more 4. We have to have at least one 5, at least one 3. Minimum possible sum is 8. After this I can add one more 3. So 9 and 10 are not possible. 11 is possible. Straight away I know that 14 is possible. 17 is possible. 20 is possible. 23 is possible. 26 is possible, etc., etc., etc. All of these are possible by putting 1, 5 and then more 3s. I have 8 is possible. Same approach, I can put more 5s. 13 is possible. 18 is possible. 23 is possible. 28 is possible. We can put 2 3s and 2 5s. So 16 will be possible. 3 3s and 3 5s. 3 into 3, 9. 3 into 5, 15. 24 is possible. If 8 is possible, any multiple of 8 is possible. 8, 16, 24, all of those are possible. If 11 is possible, any multiple of 11 is possible. So several numbers are possible. Right? Now, sitting inside all of this, we still have to find a pattern. We still not have got the answer. Right? So we're still struggling to find some pattern here. Think about this, plus 3, plus 3, plus 3, everything is possible. Now I'm going to put some algebra in. Now, if some n is possible, then n plus 3 is possible. Some number n, or n we are already using, so let me not confuse you. If some p is possible, p plus 3 is possible. If I can generate 30, I can generate 33. If I can generate 104, I can generate 107. How so? I'll just add one more 3. If some p is possible, p plus 5 is possible. Why? Add one more 5. If some p is possible, p plus 8 is possible. Add one 3, add one 5. Of all this, I like this 3. Why? Because it tells me that this is a very important point. If we can find a system where there are 3 consecutive integers possible, some 3 consecutive integers possible, then after that everything is possible. How so? Think about it. If I have, I'm not doing the number, suppose 51, 52, 53 are possible. I'm not saying they are possible. Suppose 51, 52, 53 are possible. 51 plus 3 is 54. 52 plus 3 is 55. 53 plus 3 is 56. These 3 are possible. 54 plus 3 is 57. 55 plus 3 is 58. 56 plus 3 is 59. 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62. Everything is possible. So, whenever you are cracking this, the first idea to remember, if any one number is possible, that number plus 3 is possible. Second thing to think about, the moment you have 3 consecutive integers, you are through. Everything else after that is possible. Right? Now, let's look at the sequence we did have. Right? What are the numbers we have written down? 8, 11, 14, 17, 20, 23, 8, 13, 18, 23, 28, etc., etc. Then 16, 24. We're looking for 3 consecutive numbers. 11 and 13 are there. If 12 works, we are through. If you have 12 also, then we are through. Is 12 possible? If you put 1 5 there, remaining is 7. If you put 2 5s there, remaining is 2. 12 is not possible. So 11, 12, 13, not working out. 9 and 10 are not possible. 12 is not possible. 11, 12, 13, all 3 don't work out for us. Now think about 13, 14, 15. If 13, 14, 15 work, everything else works after that. 13, 14, 13 and 14 are there. If we can create 15, we are through. 15, we must have 1 5, that is 5 plus 10, that doesn't work. 2 5s, 10 plus 5, doesn't work. 15 plus 0, that doesn't work. 15 is also not possible. So 13, 14, 15, 14, 15, 16, 15, 16, 17, those kind of triplets are ruled out. 15 is also not possible. Let's look at 16. 16 is possible. 17 is possible. 8, done. 16, 17, 18, we have a sequence. So after 16, any number is possible. We know how to generate 16. We know how to generate 17. We know how to generate 18. 16, 17, 18, all 3 are possible. That means 16 plus 3, 17 plus 3, 18 plus 3 is possible. Then that plus 3 plus 3 plus 3 is possible. Excuse me. From 16 onwards, any number we can generate. Because we have a number, we can generate that number plus 3. 16, 17, 18 in a sequence we have. Keep on generating plus 3, we'll have 3, 3, 3, 3, 3 till eternity. Or the moment we get 3 in a row, we are through. 16, 17, after 16, any number is possible. What is the maximum number that is not possible? That is 15. That is there in this choice D. 15 is not possible. After 15, any number can be generated. In all of these questions where you are worried about which of the following cannot be written, then think about what can be written. If you can figure out what can be written, what cannot be written becomes simpler. List down a bunch of things that can be written. See if many things can be written. See if several things can be written. See if there is a pattern in the things that can be written. See if you can confidently say everything can be written. Then think about, hey, maybe something cannot be written. Maybe something does not work. Maybe something still is not possible, and then go about chasing that. Don't think about what cannot be done. Think about what can be done. I can write 8, I can write 11, 14, 17, oh, there's a pattern here. 8, 13, 18, there's a pattern here. 16, 24, there's some pattern here. Now, if I have a number, what can I be sure of? I can be sure of that number plus 3. I can be sure of that number plus 5. So somewhere, if I have 3 in a row, I'm done. Then go about finding where you can find 3 in a row. Right? But thing seems to have slipped that side, so I'm going to press escape, discard this, back here, we'll do this. Try this question. Again, tough question. Read this question. I'm going to give you a minute and a half, then we'll discuss. I'm going to again pop aside and see if there are some interesting chat. Cancel the prime factors of the numbers, and number of numbers remaining is required to be robust. Okay, perfect. If 2 and 5 are considered as separate integers, we'll have to remove 4 integers. That's correct, Harsh. But we want to remove the least possible. So we'll not consider 2 and 5 as separate. We'll put them together and say 2 into 5 is 10. I can remove 10. Therefore, I'm removing only one integer and still achieving the same objective. That will work. And so 2 into 5, 10 being removed makes life simpler, juicier. That's what we'll do. Right? Super. I'm going to carry on with this question. This is again a beautiful question. A, B, C, D is a set of not 5 integers, 4 integers. Remember, these are integers, so it can be positive or negative. We pick 2 integers out of A and add them. The following 6 sums are obtained. Oh, brilliant. 0, 2, 4, 8, 10, 12. So 1, 2, 3, 4, 5, 6 different sums are obtained. So what am I taking? I'm taking A, B, C, D. Find the 4 integers in set A, B, C, D. I'm adding them, adding up some 2 of them. And there are 6 different sums possible. How is it possible? I don't even understand how 6 are coming. So let me list out the sums. We could have A plus B. We could have A plus C. We could have A plus D. B plus C. B plus D. C plus D. Count with some pattern. Including A, what do we have? A plus B, A plus C, A plus D. Including B, what do we have? B plus C, B plus D. Now I won't count B plus A, that I've already counted. Including C, we have C plus D. That's why there are 6 different sums. I'm adding all of this. Now I'm going to do a very simple, beautiful assumption here. I have set A, B, C, D. I'm going to assume A less than B, less than C, less than D. It's in some order. I'm going to assume in this order to simplify life for myself. I cannot say less than. I have to say less than or equal to, less than or equal to, less than or equal to. I cannot just say less than. They could be equal. Right? Now think about this. Could they be equal? If 2 numbers were equal, right? Let's say we have numbers A, C, D. Then some of these 2 numbers would be A plus C. Some of these 2 numbers would also be A plus C. Some 2 sums will be the same. Here the sums are not same. In a general case, if you're given 4 numbers, assume A less than or equal to B less than or equal to C less than or equal to D. In our case, A, B, C, D, we don't even have to say less than or equal to. We can say A less than B, less than C, less than D. 4 numbers in order like this. Right? Brilliant. Now we know this. A less than B, less than C, less than D. I'm adding them up. I'll get A plus B, I'll get A plus C, I'll get B plus D, I'll get C plus D, etc., etc., etc. 4 numbers like this. Now I'm combining some 2 of them. In what instance will my sum be the least? When will my total be the smallest? When I'm adding these 2. When will my total be the largest? When I'm adding these 2. Or straight away I know A plus B is equal to 0 and C plus D is equal to 12. Brilliant. These two add up to 0, the smallest sum. These two add up to 12, the largest sum. Two numbers add up to 0. A and B add up to 0. Give me two numbers that add up to 0. 3 and minus 3, 2 and minus 2, 1 and minus 1, 5 and minus 5. What do you notice? One is plus something, the other is minus something. So I don't want to deal with A and B. I'm going to deal with A and minus A. So this is A, B is minus A, or I'm going to say minus A, C, D. You can write it as A minus A, C, D. If A is negative, minus A will be positive. There's nothing wrong with that. I'm writing it like this because I feel that this number could be negative, this could be positive. I'm writing in order. So I want to think of it as minus A, C, D. What do we know? Minus A plus A is 0. Now, I have A, B, C, D. I know the smallest number is these two addition. The largest is these two. What is the second smallest? I add A and B, I get the smallest. What will be just above that? B and C? Or C and D? Or A and D? What will be just above that? I can add B and C. I can add A and C. Which will be greater, A plus C or B plus C? B is greater than A. So A plus C will be smaller than B plus C. Or the second smallest is going to be A plus C. Brilliant. So in our case, we know minus A plus C is equal to 2. The first number is minus A. Written as minus A, B, C, D. First number I am writing it as minus A. Second number is A. Third number is C. Fourth number is D. First number plus third number is the next combination. That is going to be 2. Or minus A plus C is 2. Or C is A plus 2. I am taking this minus A that side. It will be 2 plus A plus 2. Brilliant. So now we have got the numbers as minus A plus 2, D. So I started with A, B, C, D, 4 variables. Now I am down to only 2 variables, A and D. I also know one beautiful thing. I know that these two add up to 12. I'm going to use that. Why not? So I have A plus 2 plus D is 12. Or A plus D is 10. Or D is 10 minus A. Take this A that side. Why have I done that? Because I like A. I have written B and C in terms of A. I want to write D also in terms of A. Now I have got something going. So my numbers now are minus A plus 2, 10 minus A. Right? So now I am going to match them to these sums. How will I do that? Minus A plus A is equal to 0. One sum I have got. Minus A plus 2 is equal to 2. That also I have got. Then what is the largest? 10 minus A plus A plus 2 is 12. Got this also. So map this, map this, map this. Think about it. These two add up to give the smallest. These two add up to give the second smallest. These two add up to give the largest. This and this will be the second largest. Let me find that also. A plus 10 minus A is 10. Yeah, A minus A is 0. These two 0, 10 remains. That's also I have got. Think about it. I have added these two, these two, these two, these two. And the original combination, if you think about A, B, C, D, A and B I have taken, A and C I have taken, D and C I have taken, D and B I have taken. With A, I have done A plus B, A plus C. With D, I have done D plus C, D plus B. What is still remaining? B plus C is remaining. A plus D is remaining. Those two are still remaining. So let us do that. So minus A plus 10 minus A. This combined with this, that is remaining. That will be 10 minus 2A. These two being added remaining, A plus 2, which is 2A plus 2. This is also remaining. Now these two should be equal to 4 and 8. If this works, we are through. How do we check whether it works? Solve for it. 10 minus 2a is 4. 10 minus 2a is equal to 4. Or 2a is 10 minus 4, which is 6. Or a is 3. Substitute a equal to 3 here. 2 into 3 plus 2. 6 plus 2, 8. Yeah, that works. So a equal to 3 works beautifully. So a should be 3, or our numbers are 3. 3 plus 2, 5. 10 minus 3, 7. Minus 3. So minus 3, 3, 5, 7 works. Minus 3 plus 3 is 0. Minus 3 plus 5 is 2. Minus 3 plus 7 is 4. 3 plus 5 is 8. 3 plus 7 is 10. 5 plus 7 is 12. Brilliant. It works. So you've got this far. You're this close to cracking this exam. You've done magnificently. You've isolated the 4 numbers. You've written down in order. You started with A, B, C, D, 4 variables, very confusing. You brought it down to 3, to 2. You got it to 1. You finally tallied off 4 of the sums. Got this far. Fine. All perfectly fine. And then you said 10 minus 2a is 4. 2a plus 2 is 8. Why should it be like that? It could very well be 10 minus 2a is 8. 2a plus 2 is 4. Who told you the other way around won't work? So I'm going to worry about that. So I'm going to think about whether that also works. Or I'm going to say, I don't have space here. I'm going to write down here. Let me see if I can squeeze it in here. So I'm going to say 10 minus 2a is 8. Write down somewhere here. 10 minus 2a is equal to 8. Or 2a is 2, a is 1. 2a plus 2 is 4. And a is 1. 2 into 1 plus 2 is 4. Yeah, works. A equal to 1 also works, which is brilliant. A could be 1, or this is minus 1, plus 1, 1 plus 2, 3, 10 minus 1, 9. This also works. Let's check this. Minus 1 plus 1 is 0. Minus 1 plus 3 is 2. That works. 1 plus 3 is 4. That works. Minus 1 plus 9 is 8. That works. 1 plus 9 is 10. That works. 3 plus 9 is 12. That works. Or both of these are possible. So if you have to get marks in this exam or in any exam which is serious of any stripe, not only must you get the right funda, you must see it through. Not only must you get an answer, you must get all the answers. So if you have done really well and you've got this answer but not this, very likely that you've earned yourself negative marks in many competitive exams. You might have left this question and got 0. You might have tried and got this far and got yourself a minus something. Not worthwhile. So as a mathematician, as a student, you've got to tell yourself, okay, I've got the right approach. Have I covered all my bases? Do I know that I've got all possible answers? Or am I still in a place where some answer could still be missing? It's out there. So when the moment you say, this is 4, this is 8, a part of your brain should say, what if it were the other way around? And you have to go and verify that. And so you have to get comfortable dealing with A, B, C, D, M, N, all of that. Using the variable part is very important. But you have to get the detail right and you have to worry about that missing answer. So don't forget about that. Finally, you might get all the way and get one answer and miss out on the other one. So be very wary of that. Okay. Lovely. I think we're not doing great on time. So this is 2 possible answers. Last question, it's a fun question. Let's think about this. 3 counters A, B, and C are colored with 3 different colors, red, blue, and white. Of the following statements, only one is true. Right? What is the color of each counter? Only one is true. Right? So there is A. All of these questions are going to be based on trial and error. How so? Only one is true. Lovely. So let's say this statement is true. Right? So if that statement is true, A has to be red. Now remember, we have said let the statement 1 alone be true. That means these 2 should be false. Statement 2 says B is not red. That's not possible. That will also be true. A is red. That means B cannot be red. That means if statement 1 is true, statement 2 has to be true. Therefore, this alone being true, that is ruled out. Very simple assumption. Only one statement is true, that is being given. I'm starting off by saying, let that be the first statement. Let us see if there is a possible scenario where only the first statement is true. The first statement being A is red. If that is true, B is not red. So the moment you say the first statement is true, second statement also has to be true. That's not possible. Only one statement has to be true. So that one statement, only statement that has to be true is not this one. Let's go to the second one. Let's assume this alone is true. That is, B is not red. And so B is not red. That means B can be, what are the other colors possible? It could be blue or B could be white. Right? So B could be blue, B could be white. We have assumed that that is the only statement that is true. Right? Or the first statement has to be false. That means A cannot be red, otherwise that will end up being true. B is blue, A cannot be red, or A has to be white. In this case, C has to be red. Or if B were white, A has to be blue, C again has to be red. Lovely. We've assumed the second statement is true. If the second statement only were true, this is possible, this is possible. Let's see. Now the first statement is not true, second statement is true. Third statement, C is not blue. That is also true. C has to be red. C is not blue. So we cannot have a situation where only statement B is true. Only one is ruled out. Only two is also ruled out. Now worry about the possibility that only this is true. Only one being true, not possible. Only two being true, not possible. Now let's go to this one. C is not blue. So A, B, C. C is not blue. That means C could be red. It is not blue. That means C could be white. Lovely. Now let's go to the first statement. A is red. That should not be true. In this case, that won't be true because C is red. In this case, A is red is not true. C is white. A is not red. I mean, B should be red. A should be blue. Let's see if this holds good. In this case, statement 1 is not true. Statement 2, B is not red. B is red. Statement 2 says B is not red. That also, statement 2 is B is not red. That is false. C is not blue. That is true. So this works. This combination will work. If the first one were blue, second one were red, third one were white, then A is red, not true. B is not red, not true. C is not blue, true. Two of them being false, only one being true, that is possible. In this case, C is red, A is red, B is not red. That statement has to be true. So that statement has to be false. Because we're thinking about a scenario where only statement C is true. That means this has to be false. That means C has to be red. That's not possible because C is already red. B and C both cannot be red. So all combinations here are ruled out. If C were red, B cannot be red. If C were red, this statement is not true. Then B is not red, that will also be, this statement will be true, this will also end up being true. Both cannot be true. We are working for a scenario where only one statement is true. So this combination is ruled out. Or there is only one possible combination where only one of the three is true, which is the combination where A is blue, B is red, C is white. Under that particular combination alone, we'll have a scenario where the first one is false, second one is false, third one alone is true. Nothing else is possible. So what is the color of each counter? A is blue, B is red, C is white. That works. Wonderful, wonderful session. I quite enjoyed myself. We will have a session on Thursday and then the subsequent Tuesday after that. Please do try the questions beforehand. It's very tough to try the questions in the context when it is being taught right there, right then, with time pressure thrown in. So make sure that you visit the page, try out the questions beforehand. So get the questions ready, try them before you come together for doing this. Fine. Lovely. Sure. Have fun.